But before I start answering questions, I'm going to tell a story about how I almost didn't get here, which illustrates some of the perils of 21st century digital technology. So, I've never been to this building before. Wanted to be sure I got here on time. No problem. I've got this smartphone, and it's got Google Maps on it, and I typed the address into the smartphone, and it gave me directions. And we were almost here, and my phone went to power saver mode. Please put the phone in. So yeah, smartphones, clouds, ubiquitous computing, good. Battery technology, not so good. This is a serious Achilles heel. Okay, with that out of the way, let me try and knock off some of the easier ones of these questions. Now, I'm going to be looking around the audience as I answer, and I'm going to be looking around for a reason, because when I hit a natural pause point, I want you people to interrupt with questions. That's the goal here. I discovered a long time ago that I don't like standing up and lecturing. I like to jam with my audience. You are my audience, we are jamming. Okay, some of the easiest questions first. You wrote an article with the title, Why Python, back in 2000, which was published in Linux Journals. A follow-up to this article, is Python still your go-to language? Why, yes, as a matter of fact, it is. I realize I'm in front of a Java users group, but let me rant about languages for a bit. Yes, I really like Python. I like it for a very specific reason. I like Python because of all the languages I have ever used, it is the one that maximizes ease of long-term maintainability. That is, the ease with which you can read your code 6 months later. And the longer I program, the more convinced I am that that is the most important metric of a language, bar none.
Here.
Since I'm in front of a Java users group, I'll tell you that my history with Java is kind of peculiar. I was actually one of the technical reviewers for the original Java spec, because one of the language designers is an old friend of mine. But because of this, I made a point of not learning Java at the time, because I wanted to be able to critique the report from the point of view of a sophisticated outsider. I still haven't actually learned Java well enough to do more than a couple hundred lines of programming in it. I don't dislike Java, but I think it's a little over verbose and has become kind of top-heavy. So it's not my first choice, but if I had to write something in Java, I wouldn't go ick. As opposed to, say, C++. Yeah, I have done C++ programming. I'm a senior developer on a project called Battle for Wesnoff. Anybody here know about the yeah, if you like the writing in Battle for Wesnoff, the prose, that was me. I spent 2 years bringing the prose up to snuff. And at one point, I actually was doing C++ for Battle of Wesnoff. I rewrote the game's interface once. That was kind of fun. It was kind of entertaining to be simultaneously the oldest, crustiest Unix geek from the days of 300 baud teletypes in the room, and also the user interface guy. Okay, yeah, that was entertaining. But the worst C++ programming I ever had to do was we had a developer who kind of did a drive-by on us. He showed up and made all the right noises and sounded competent, and said he wanted to improve the game's AI. So we gave him commit access and let him go at it. He broke the AI and disappeared. I was the person who had to go in and do the meatball surgery on the AI to revert it to the state where the game was actually playable. That was my I will never write C++ again experience. Oh, it was hideous.
What, no version control?
Oh, no, we had version control. The problem was the changes I was trying to revert were intertangled with other changes that we wanted and needed to save. So it was not a trivial revert operation to back things out. It was very nasty. And the reason I'm uttering this rant is because C++ has the exact opposite problem to the virtue that I called out in Python. Long-term maintainability of C++ code, terrible. I mean, okay, the best thing I can say about that is it's not as bad as Perl. But I'm afraid that constitutes damning with faint praise. No, I like Perl fine and occasionally use it, as long as the program isn't more than 25 lines long.
Everything one line, right? One line.
No, that's APL.
Oh, okay.
Yeah, that's everything in one line is APL. So most of the programming I do these days is either in Python or C, and I'm happy with that. I'm sort of gingerly dipping my toes into the waters of Go, Google's new language. I don't know if I like it yet, but I'm going to learn it by writing a client binding in Go for GPSD, and that should teach me enough so that I know if I like the language or not. So, any questions pertinent to that one? Yeah?
So what are your thoughts on the JVM becoming like a more general purpose, language interpreter running things like Jython and
Right.
JRuby?
Yeah, he wants to know what I think of the JVM being everywhere as infrastructure for other languages. I'm mostly okay with that. I think the JVM has some deficiencies near word length, and there are some serious problems with the numerical tower. And you need to talk to numerical analysts for details on those. I just know they're there. I don't understand them very well. But I think it needs some work to be a really robust platform. It's good, but it's not as good as it needs to be, is my opinion. Any other questions? Yeah.
I guess I programmed in countless languages, and so many I can't remember. But back in college days, we had a book, a blue book that had like 500 languages were summarized in this book in the Tower of Babel. And, I mean, here we are this day where we're talking about interpreters for interpreters and new interpreters and this and that and everything else. And every time you turn around, you got some guy saying language X.6 is better than this and everything.
Mm-hmm.
How do you cope, and how do we make any sense out of our profession? I'm a senior level guy, but somebody says, do you program in Java for the last 6 years? And if not, you're not worth anything as a human being. Never mind, we're not going to hire you. In this Java haven here, but
if you're that senior, the
we
policy I advise to you is lying through your teeth. Now, this is not a policy I advise for junior programmers, because junior programmers can't learn languages fast enough to make good on the lie.
I understand that, but the problem I see is that where do we go with any integrity and stuff in our profession and stuff? And it's like I keep asking people, how many ways can you describe how to add two numbers together? How many languages do we need?
We'll keep saying language invention until people get tired of inventing them. I'm sorry, I don't have a solution for this problem. Any other question over there?
Yeah, what do you think of Ruby?
Ruby, I've dipped into Ruby a little bit. There was a point at which I had to modify some Ruby code for a project I was working on, so I think I understand the language a little, maybe not master level. My impression of Ruby is that it has pretty much the same virtues and the same problems as Python, and I might be tempted to switch, except that it's not different enough. Functionally speaking, of course, aesthetically there's all kinds of odd little differences. But it's not different enough from Python to make me move. That's my impression. So let's knock off some of these other questions. Do you see any incongruities with APIs as the basis of cloud and the FOSS model? Oh, note by the way, I hate FOSS. That's a weasel wording made up by an academic. Just call it open source. Do you see any incongruities with APIs as the base of cloud and the FOSS model? I'm not sure I understand that. Does anybody think they understand that question?
What's the name on the bottom of the question? Let's call them out.
It was via Twitter. Do you see any incongruities with APIs?
Is Twitter here tonight?
Okay, we're going to ignore this one.
I have an idea. I think it's that you can hide behind the GPL and put it on a cloud server and not distribute software. So you don't have to push back.
Oh, right. So my answer to the question, to all questions of that kind, is if you don't like the provider's business model, don't use them. There's no point in getting in vast theoretical, theological disputes. The right answer is if you don't like the provider's business model, don't use them. The market will sort it out. One to start a rant. Oh, yes, this is. Should it be called the GNU operating system with a Linux kernel or the Linux operating system with the GNU tool chain? I don't care. I so don't care. Furthermore, I advise an attitude of aggressive not caring for everybody. Please do. Anything I say here is quotable.
It's on tape.
Okay, and a serious one. Why would anybody license open source software under 2 open source licenses? That's really easy. That's so people who are frightened by the prospect of GPL viral contamination can choose the BSD instantiation and not worry about it. I think this is actually a good idea. Partly because I think at this point, this is one of my more incendiary opinions, I don't think we need the GPL anymore. Would you just stop?
I was the person who asked that question.
Yeah.
And yeah, if you're going to do one open source license, pick the one that's most permissive.
Pick the
Why
permissive
go
one.
with
Yeah.
the other one? I can
I agree with
understand commercial and GPL,
Yeah.
as we saw with Oracle's opening arguments.
Yeah, I agree. If you're going to do that thing, just pick the more permissive license. But my attitude in general is just use permissive licenses. Stop with the viral stuff. And the thing is, the GPL made sense when we were all terrified. When we saw ourselves as a tiny little beleaguered island surrounded by huge-toothed predators. Well, the rest of the world is afraid of us now. Because we've been doing so well and being so productive. And most of the people out there that we want to deal with understand the incentives involved in open source and how the economics works in our favor. And it makes them want to cooperate with us. And if they don't want to cooperate with us, screw them. Yeah, yes, I know why. I think I know why you have your hand up.
No, it won't be hostile, even though I met myself.
I wasn't expecting hostile, but I was expecting probing.
Probing, yes. Okay, so we're not scared now,
Yeah.
but we might be only one Supreme Court decision away from being scared again. So I think we still need some kind of protection on legal footing against having freedoms that we've achieved being taken away at some point in the future.
Nobody can take those freedoms away from us anymore. We have the internet. We have the internet. We have a way to migrate our software development out of the reach of any particular jurisdiction that goes idiotic. We have the code. They can't take the code away from us. Okay? If you want to worry about defense against political attacks, defense against political attacks is a very reasonable thing to worry about, and in fact, I've done my share of mobilizing people against things like PIPA and SOPA. But that's not a battle that you need to fight with licensing provisions that make lots of people frightened of you. And the truth about the GPL is it scares the shit out of a lot of corporate lawyers, and not without reason. It's slowing down our adoption rate. We should dump it. That's my incendiary opinion. Let's see. In your book, The Art of Unix Programming, you discuss the Unix principle of silence is golden, where programs do not return messages, statuses, etc., unless something is out of the ordinary occurred. As a fan of the command line myself, I very much agree with this principle. However, most of our general computing today relies heavily on graphical user interfaces, which of course have their own advantages and disadvantages. Do you think designers could take any user principles from Unix and apply them to benefit existing new interfaces being developed? And if so, what and how? Well, one of the design principles we could take from Unix is the astonishing concept that you shouldn't write a GUI unless you need to. Because if you need to write a GUI, the most appropriate thing you can do is decouple it strenuously from the engine of your application. Do the kind of thing that, for example, the GIMP does, where the entire application functionality of the GIMP is structured as a library which optionally has a GUI interface, optionally has a command line interface, and also optionally presents an API so that it can be scripted by other programs. And that, because you want that kind of polymorphism, is the best reason not to write a GUI unless you have to and until you have to. Try to layer your application so that there is proper separation between the details of the interface and the implementation. This isn't easy. It is especially not easy in user-facing applications where the interface and the details of it are extremely important to your target market. But the fact that it is not easy does not remove the necessity of getting your layering right. And that is, again, why I say avoid writing GUI until you have to. Figure out what your application space primitives are first. And I realize that if there are any Macintosh designers in the room, they are now blanching and turning green, but hey. Let's see, are there any others of these that I want to tackle now?
Eric?
Yeah.
Quick question on the last topic. When you say avoid writing a GUI until you need to,
yeah.
Are you assuming a kind of a certain sort of user?
What was that?
Are you assuming a certain type of user?
Well,
for developers,
pick an application type. Pick an example application case, so I can use it to answer your question.
Business process.
Okay. Well, you're saying you have a business process application, and your assumption is that it's going to be used by a whole bunch of manager and non-technical types who are really going to want a GUI. Okay, so you're going to have to write a GUI at some point. But my claim is, the very first thing you should be doing is figuring out what the right semantic objects are in your business process space. Writing the logic to manipulate those, and then thinking, how can I present the handles on that logic in ways that are manipulable either through a GUI, or through a scriptable API, or through a command line? Does this make my answer clear?
It is. I'm just kind of curious where the separation of, like write a REST API or some sort of API, or don't program to the GUI.
Well, the approach that GIMP takes is that the fundamental separation between application and interface takes place at the level of a well-defined and documented API, which is then plugged into both a command line interface and a GUI. And this is the GIMP is not the only thing that does this. You also see this a lot in modern version control systems that are partitioned the same way. Subversion, for example, not that that qualifies as particularly modern anymore, it just happens to be on my mind recently.
Well, that's, so when I write stuff in the command line, I assume developer, and when I go into business folks and try to make it as idiot-proof as possible, the CLI just scares me.
What was that?
The command line just scares me when I give it over to business folks.
Well, you don't expect the business folks to ever use the command line. The point of writing a command line interface isn't so the business folks should see it. You never want them to see it. The point of writing the command line interface is so that you, as the developer, can, for example, script regression tests. Really hard to do through a GUI.
Sorry.
Yeah?
On the same topic, oh, I'm sorry. You're pointing to me?
Yeah, I'm pointing
Okay,
at you.
on the same topic, aren't you really just saying enforce strict architectural boundaries between your interface and your core application?
He says, on the same topic, aren't you just saying just enforce strict architectural boundaries between your interface and your core application? And my answer is, why, yes, that's exactly what I'm saying. The thing is that people get people get hung up on the idea that they need to design from the outside in, from a set of UI requirements in, and as a result of getting hung up that way, they miss the importance of this kind of layer separation, which is why I keep re-emphasizing, think about the layer separation first. So, are there any others I can knock off really quickly? Okay, I have a bunch of questions here about open source business models and bringing open source inside a corporation, capturing the magic. I'm going to try and say something general and useful about this, which is that if you're thinking in terms of bringing open source inside the corporation, you've already failed. That's already thinking in the wrong direction, because you're trying to figure out how to control and make safe a process that thrives on lack of control and no safety. Well, you know, other than good code review. So instead of thinking about how to bring open source inside the corporation, the right kind of question to ask is, how do I start up an open source project that benefits my corporation, build a community, and then sell it to my bosses? Because one of the iron laws of dealing with bureaucracy is it's easier to get forgiveness than permission. You know, if you go to JRandom line manager, even now in 2012, and say, hey boss, can I start an open source project so we can do wonderful things with this business process thing? What kind of response do you think you're going to get? No. What you need to do is you need to operate like a guerrilla. You need to be where middle management's job, which is saying no to preserve the organization's processes, you need to be where middle management isn't. So that's why how do I bring open source inside the corporation is not really the right question. The right question is, how do I start an open source project that will interest my bosses, get it viable, and then sell it to them once I have a benefit that they can see? And you know, that question kind of answers itself.
I think one of the problems with that, though, and I don't know what your opinion on it is that kind of one of the many conditions of employment these days is that things you write, even on your spare time, are still owned by the company that employs you.
There is.
So you have to get permission to.
Yeah, there is almost no court in the United States that will actually enforce that. It doesn't hold up in court when they test it, so ignore that. He said that most corporate contracts have a work for hire provision that says that anything you write while you're employed is owned by the corporation, even if it's in your spare time. So what I'm telling you is ignore that, because there basically isn't any court in the United States that will enforce it.
You can get out of that on the constraint that the company you work for cannot impede on your right to thrive.
Yeah, it's true. It's a phony terror. Just don't even worry about it. Yeah.
Okay, if you already work for a company that uses Linux-based systems, open source tools, and all that.
Well, if your company's already using open source tools, half the cultural barrier has been breached already.
Right. So how do you push them the rest of the way and start contributing?
Show them a benefit. Don't say, we could do this wonderful thing if you authorized me to spend N hours with no obvious visible return. That's something a manager is always going to say no to. What you have to do is show them a benefit. Works much better, for example, to find an existing piece of open source software that is fairly close to solving a business problem and going to your boss and saying, you know, this thing already works and it already has a user community and I can show you where it's deployed. Give me 50 hours and I can turn it into something that will solve our problem too. At that point you have a much better pitch, because that's the kind of trade-off your manager is used to thinking about.
But that's actually the opposite of the question I'm asking.
Oh, yes?
It's, you know, when you've got your in-house extensions and
oh, how to get them thrown outside?
Yes.
The argument, the universal solvent argument that works for that is to say, hey boss, how would you like to reduce your maintenance costs? And lay off the work on other people so it's not coming out of your budget. That's the reason for open sourcing stuff that was developed in-house. You want, the argument for that is cost spreading and risk spreading. And you want to put it exactly that way. Hey look, I'm going to reduce your bottom line expenses. Okay, let's see if we can knock off another one here. Wow, we've actually been through most of them. We've got some questions about business models. Unless you've got really specific urgent ones, I'm not going to try answering those. I'll just tell you to go read my book. Because I actually talk about, I mean, it's a decade old now, but the section on business models in the Magic Cauldron is still fairly current. Here, a question about corporate open source. Cloud and OSS, historical business models and how they've worked. You know, we have mostly covered the prepared questions now. So, open season. Somebody who hasn't asked a question before. Way back there.
Thanks, Eric. I'm just curious, another hot-button issue for programmers is coding standards, names, conventions, documentation, things you attach to the name of the variable to indicate some kind of aspect of the variable. And I'm just curious, do you have any observations or thoughts over the years of what you've seen in various open source projects, how naming standards, coding conventions have been followed, and pros and cons?
Okay, let me repeat the question. I've had a question about the pros and cons of coding standards, which I presume unpacks to how anal should we be about them, and how I've seen them be followed or not followed in open source projects. My first overarching observation is that the smartest thing you can do is choose a language in which coding standards are not necessary because there's a uniform style that the language semi-enforces. And yes, I have Python in mind. Go also has this property. It's very difficult to have indent style variations in Go because of certain properties of the syntax. Smartest thing you can do, if all other things are equal, is pick a language where you'll never have coding standards wars. And the reason that that's a high utility thing to do is, of course, the purpose of coding standards is to maximize readability of the code and long-term maintainability. And yes, I do think that's extremely important. See my answer to the question about favorite language back at the beginning of the talk. The smartest thing you can do is pick a language where it doesn't become an issue. If you can't do that, and in particular if you're writing in C, then the thing to do is pick a coding standard, but don't try being too anal about it. I mean, there comes a point at which the effort to enforce every conformance to every minutiae of a coding standard is causing you more pain and overhead than it's actually worth in reduced maintenance costs. So you know, try to be rigorous, but also try to relax. There's a fine balance there. Yeah, that's what system architects are for. There isn't a cut and dried answer to this one. Next question.
This is actually a comment, it's not a question. In my experience, most people try to substitute coding standards for code reviews. And that's
a good point. He says most people try to substitute coding standards for code reviews. That's true, and it's not a good idea. Don't do it. Oh, I should mention that one thing that can be your friend is if you really, really care about uniform syntactic appearance, then just use a mechanical code formatter. There are plenty of those. Find the settings that are aesthetically pleasing and just use it. One reason this discussion is less interesting than it would have been 10 years ago or even 5 is because a major important thing about coding standards back in the day, and I'm standing in front of John Tull, and he will be able to remember when I wrote a coding standard for the company we were working at.
And I can tell you right now, there's only one true brace style, and it's mine.
And he said, I can tell you right now, if there's only one true brace style, it's mine. I don't, as I recall, we didn't specify a brace style in our coding standard.
That's because we had that battle all the time.
No, but there was another reason, and it ties directly into what I want to talk about now. Back in the day, the most important, the burning issue in code standards wasn't actually one true brace style versus anything else, or what kind of indentation you were going to use. It was what subset of the thicket of APIs out there you thought you could actually count on. The major concern in coding standards back then was how do we avoid having serious portability hassles by using corners of the API that aren't actually supported on our range of platforms. Well, thankfully, we have single Unix standard now, and we have POSIX, and one of the nice things about the last decade is, as a way of avoiding portability problems, this actually works. I've actually been through the experience. I did this with a couple projects of mine that date back to the 80s and early 90s. I've actually had the experience of realizing, wait a second, this thicket of portability conditionals that we put in way back when it was necessary, I can just remove all this crap now. And count on single Unix standard being there, and maybe I'll lose deployment on like maybe 1 or 2 machine types that are 15 years old. I don't care. I don't care. So that's something I want to highlight, which is really the ground of coding standards. The ground under coding standards has changed. We don't have to worry about APIs so much anymore. So that tends to focus people's attention more on things like indent styles, which are not insignificant for maintainability, but it's not really the most important part. So don't spend your time stressing out about it a lot. Next question.
What are your thoughts on functional programming? Do you have an opinion one way or the other? Do you like
What are my thoughts on functional programming? Wow, boy, there's a can of worms. Okay, so the first thing you need to know about me is in this connection is that I'm an old Lisp head. I didn't exactly cut my teeth on Lisp. I actually cut my teeth on APL, which is even more obscure. But the result of the first 2 languages I learned is that I have this mental measure of programming languages adhesiveness. A programming language is adhesive to the degree that it sticks to your brain and cannot be displaced from your brain except by a language that's more adhesive. So I learned APL first, and then I got exposed to Lisp. And this was in about 1978, and so thinking the way I do, and I was a mathematician in training at the time, which exaggerated the tendency even more. My first question is, which one of these languages is more powerful in a practical sense? Yes, I know, they're all Turing equivalent. But which is more powerful in a practical sense? And so I decided to test the question by writing 2 toy implementations. One of an APL interpreter in Lisp, and one of a Lisp interpreter in APL. I don't think anybody in this room is going to be in any doubt which implementation worked better, and that's why I switched to Lisp and discovered that Lisp is more adhesive than APL, and it displaced APL from my brain. Nothing has displaced Lisp from my brain. I have not encountered any language that is more adhesive than Lisp. Which is not to say that I use Lisp a whole lot, it's just that it still dominates the way that I think about programming. So yeah, I like functional programming. I've even dipped my toes into Haskell. Ooh. Which someday I'll have to do a significant project in Haskell. That time is not yet, though. I haven't found anything for which it's obviously better than tools I'm already using. The problem with languages like Haskell is, okay, to explain this problem, I'm going to have to be terribly immodest for a few seconds. I am one of the more skilled programmers in the world. I won't say one of the most skilled programmers, but I'm up there on the bell curve. And I have digested dozens and dozens of computer languages in my mind, in my time. And I used to be a mathematician with a specialty in formal and foundational logic. With all these credentials, Haskell makes my brain hurt. So if Haskell and other pure functional programming languages make your brain hurt, that's okay. Because, and the thing that worries me about them is if they make my brain hurt, how the hell are they ever going to make traction with people who didn't used to be foundation logicians with a specialization in logic?
So what is the attraction to it then? What's the benefit?
Well, okay, so let me go through my worry first. My worry is that these are beautiful tools that will never actually achieve mass acceptance because they're simply too hard for most programmers to use. And so the question that was asked was, what is the attraction then? For the class of problems that is easily addressed using a functional language, using functional languages produces solutions that are breathtakingly, devastatingly elegant, beautiful, and terse. When the tool matches the problem, there are very few things in the universe more lovely than a properly designed functional problem. The issue, though, is A, the tools are difficult to comprehend, and B, I said when the problem matches the tool. There are lots of problems that don't match functional programming language tools because functional programming language tools really want to live in a universe where everything is stateless and all transactions are reversible. Uh-oh. I mean, you run into problems with those assumptions the moment you deal with messy things like input-output operations. Intrinsically not reversible. So a lot of the cruft, the complexity in functional programming languages arises from this unavoidable interface, this energy barrier between the programming language's internal world of pure logic, statelessness and reversibility and infinite backtracking, and the messy exterior world where we actually have to deal with stateful objects. And so I don't have a final answer to this question. They're fascinating tools. They're good for some classes of problems. I love them aesthetically. I don't know if they're ever going to be more than a small minority preference.
Would you say that there's value in becoming a skilled user of a functional language in order to develop the mental discipline to separate state and transition?
Not only would I say that, it's exactly what I was going to say next. I'm going to repeat the question in the form that I originally had the answer buffered up in my mind, which is nevertheless, even though these tools may never get huge traction, learn one anyway. Because there's this, when you get deep enough into any functional language, for me it happened with Lisp, for other people it could happen with other languages. When you get deep enough in any functional language, there will come a point at which you will achieve satori, you will achieve enlightenment about how functional programming actually works, and your entire universe will lurch sideways and never be quite the same again. And even if you never use a functional programming language for a line of code after that, it will change the way you think, it will change the way you form abstractions, it will clean things up. Yeah?
It's also, what does that mean? It's also changed, the languages, Java and Python, have also changed to seem a little more functional than they used to be.
It's been pointed out that Java and Python look a little more functional than they used to. Ironically, actually, in the case of Python, Guido actually doesn't like Lisp. And his personal preference would be to take the functional constructs out of the language. But every time he does that, a bunch of his friends and senior developers, including me, look at him and go, you will take away my lambdas when you pry them out of my cold, dead fingers. This off the floor so I don't trip over it. Okay, next question.
What are your thoughts on Scala as a language?
It's on my list of languages to learn. I have a friend whose judgment I trust who says it's a very good design, and that's enough reason for me to go look at it. But I haven't had a chance yet, so I can't give you a detailed review. So, what time is it? 7:45. One of the things I wanted to do is simply because I think, you guys would find it interesting is talk a little bit about some adventures I've been having recently. Are we sufficiently short on questions that I should do that? Also, I'm noting that it's now 15 minutes to our stop time. Okay, yeah, back there?
I have just one question.
Yeah.
From one of the first things you said this evening.
Yeah.
In what ways would you say Python is more maintainable than Java long term?
You can read it 6 months later. The advantage of Python over Java is that it's less heavyweight. There isn't a huge syntactic thicket of declarations and codicils and stuff that, from a point of view of Python programmers, is sort of extraneous junk that just gets in the way of comprehension. There are languages that are much worse that way. See my rant about C++. But yeah, Java is a bit too syntax heavy and cluttered for optimum long-term maintainability. That's my opinion anyway. Yeah?
Do you think COBOL will die off, and how long?
Never.
He says, do I think COBOL will die off? And John Tulp just muttered never, and he's right. COBOL, for our sins, will never quite die. So now I think I'll sort of wander through some of the adventures I've been having lately, because I think you guys will find some of them interesting. And I will note that it is 15 minutes to stop time. I do not have a hard stop. When it comes to 8 o'clock, those of you who want to wander off and stop being bored can do that. Those of you who can still ask questions, I can hang around for a bit more and field some more questions and jam with you all. So the main adventure I wanted to talk about recently, that I've been having recently, is a really nifty one. So you've heard me say that I used to be a foundational mathematician. As a programmer, I sort of descended from the clouds of abstraction. I started off in mathematical logic, then I learned Lisp, and then I learned C, and my career has been more or less in this direction, from the clouds to the metal. And recently, I reached the metal. Here's how it happened. I'm involved with a project called the Buffer Bloat Group. Any of you heard about this? There is a problem in the infrastructure of the internet, we think. We know some of the symptoms. We don't know how severe it actually is. It could be really severe. In the worst case scenarios, it could actually induce a total internet congestion collapse. But that's not very likely, and we're working on the problem. The problem is that the queuing strategies used in TCP/IP implementations are mostly for shit. They overbuffer in particular, and the result of the overbuffering is they don't tend to send congestion notifications downstream or upstream, which defeats some of the routing mechanisms that TCP/IP has. And they also tend to turn smooth traffic into lumpy traffic, because it's like a capacitance in effect in a circuit. If you have a poor queuing strategy, you have a continuous stream of data coming into a buffer and being released as chunks. Bump, bump, bump. Okay, so what the result of this is that bad buffering strategies tend to produce and exacerbate chaotic behavior in the network, chaotic traffic flows. The symptoms of this include huge, unpredictable latency spikes. We suspect strongly that a lot of the internet problems, dropouts in your videos and so forth, that get interpreted as, oh, there's not enough capacity, we need to build more bandwidth, are actually chaotic latency spikes produced by crappy buffering strategies. And as I say, in the worst case, some of our people are speculating, and some of our people include people like Van Jacobson, who designed the original anti-congestion algorithms. Some of our people speculated that in the worst case, you could get ringing effects, oscillation effects in the internet that would cause a complete congestion collapse. We don't think this is very likely, but we think it's worth worrying about enough about that we should do some mitigation, especially since the mitigation methods will make throughput better for everybody by eliminating the latency spikes. That is, no more dropouts in your videos, et cetera, et cetera. So some of us have been thinking about this, and some of us that have been thinking about this include Jim Geddes, who a lot of you will know is one of the designers of X, And Dave Tott, who is not as well known, but probably should be. He's one of the co-inventors of the Linux wireless router. He was part of the team that built the original one. And myself in a relatively minor role. I'm not one of the project leads. I am the person that Dave Tott recruited to solve a problem, which is that one of the things that we think the latency spikes may be screwing up is network time protocol. Yeah, because network time protocol relies on some assumptions about symmetry of packet transit times, which if you have sufficiently bad, sufficiently short period latency spikes, are actually violated. So we may actually have serious NTP clock skew that we can't detect because of these latency spikes. In order to check, and if you're getting the feeling that like you're turning over a rock and there's lots of slimy stuff underneath, that's what we feel like. Because once you start thinking along these lines and looking for the latency spike effects, they're everywhere. They're screwing up lots of stuff. So in order even to get a handle on the problem, we want to install what Dave Tott calls the cosmic background buffer bloat detector. And his plan is to install a whole bunch of routers, TCP/IP routers all over the world, all of which are handling and forwarding normal traffic as usual, but they've also got monitoring software to measure packet times so that we can, in effect, get a latency map of the internet. And Dave wants to use, in order to collect the actual propagation statistics, Dave wants to use NTP raw statistics. See, NTP has to collect propagation statistics about the time, the traversal time over the various links that it uses, because that's how it knows how to compute clock delays. So, okay, that's fine. But remember when I said we may not be able to count on NTP? We can count on NTP's propagation delay statistics, probably, but we can't count on its actual time base, because that's one of the things that may be broken, which means one of the things that each one of the cosmic background buffer bloat detector routers needs to have is its own local time source with a common time base independent of NTP. That way, you see, we can meter NTP to see if it's working properly. And if it is, we're golden. We can do all the stuff we want to do, map the latency problems, figure out if there are any serious issues in the internet core, and so forth. So this is where I come in, because Dave happens to know me, and he said, oh, Eric's been doing a lot of work on GPSD. You all know about GPSD? It's a GPS service daemon, monitors GPSs and other navigational sensors, and in particular it can use GPSs as high precision time sources. And it's one of the main ways that people feed NTP nowadays, and I'm the lead on that project. Dave Tott knew this, and he said, gee, Eric would be a good guy to talk to about precision time sources for our network monitoring. The fancy computer science name for this, by the way, is network delay tomography. That's what it's called. I didn't find that out until I was already like months into the project. So he came to me and said, can you solve our time source problem? And so I went off and diligently did a bunch of research. And it turns out conventional GPSs aren't quite good enough, because they only report over the ASCII or ASCII stream that you get over serial or USB. They only report time to at 1 second intervals, and at the best you can normally get is 100th of a second precision. But as it turns out, if you actually profile these things in real time, there's like 170 millisecond wobble, random jitter in the time reports. And since the time scale of NTP events is 10 milliseconds, that's just not good enough. So conventional GPS is right out of the question. I looked into the things that physics laboratories use as high precision time sources, which are GPS conditioned rubidium oscillators, and they're as expensive as that sounds. It's 10 grand and up typically for these things, and they have way more precision than we need. They're like down to like nanosecond range, and we don't need more than a millisecond.
There are GPS receivers specialized for time reporting.
Yes, there are. I'm getting there. There are GPS receivers special. There is a way to get high precision time out of a GPS. And we are wandering towards the point at which I start designing hardware here, so have patience. There is a way to get high precision time out of a GPS. All GPS chips emit a signal called 1 PPS. This is what you were thinking of. It's called 1 PPS. It's emitted at the top of the GPS second, and it's guaranteed to be within 50 nanoseconds of Naval Observatory atomic clock time. Sounds perfect, doesn't it? Well, there are a couple of problems. The main problem is that historically, the only way to get this PPS signal out of the chip was to use an RS-232 interface and connect the 1 PPS signal to one of the handshake lines, typically DCD, although we sometimes did see ring indicated. Well, this is a problem right here for the general reason that nobody uses serial interfaces anymore. And for the specific reason, well, there are a couple of things. Serial interfaces are dying. It's very hard, as it turns out, to find serial interface GPSs anymore. And even if we had those, the cheap routers that we want to use, none of them have serial ports. Who puts a serial port on a router? It's all USB all the time these days. And that's actually a good thing in most contexts because GPS devices can be self-identifying and so forth. But in this context, it gave us a problem. What we really needed, as it turns out, was a GPS that exports 1 PPS, this top of second 50 nanosecond precision pulse, as a USB event. So I went looking for those, and I found one, made by a tiny company in France, and I talked to their North American distributor, and this is a little GPS dongle with a Trimble chip and a USB serial adapter, like a PL2303 or something you could get for a couple cents each. So, you know, $30 worth of parts. The North American distributor wanted $900 for each one of these. We went back to the company that manufactures them in France, and it turned the best price they were willing to give us was the equivalent of $225 American. This is for a device that I know has no more than $30 worth of parts in it. They said we hand manufacture them in small lots. My reaction was, see ya. So now I had a problem. I know how to solve the problem, but I don't have the hardware. And I've been doing research, and I figured out something, which is that there's a really your basic generic USB GPS design is really simple. It's got a GPS chip, which is emitting a bunch of signals, including 1 PPS. The most common GPS chip is a thing called a SURF2 or SURF3. 80% of the GPSs out there use that. And it does have a 1 PPS output. There are other such chips. It doesn't matter. They're all functionally pretty close to equivalent. They all emit RS-232 data at TTL levels, and they all have a PPS pin. The other thing that goes into one of these GPSs is an RS-232 to serial to RS-232 adapter. The most common one is a thing called a prolific logic 2303. There are a couple of others, and the companies that put out these GPSs by the ton are making silly little circuit boards with 2 chips on them and a USB connector, and the 1 PPS line goes to an LED, and that's what makes it blink 1 per second when you have a fix. That's all they're using it for. And we're done. That is your generic standard GPS. So now I looked at the problem, and I looked at the USB standard, and I realized, wait, this is really simple. If you take the 1 PPS line from the chip, and you wire it to the DCD input on the USB adapter, the right thing will happen. Because all USB adapters need to ship events to the driver on the host side that simulate handshake lines. The handshake lines don't physically exist, but the USB adapter has to emulate them. You know why? The answer is modems. COM software talking to USB modems needs to be fooled into thinking it's seeing an RS-232 device. And that is why this serial adapter device class in USB one of the things all of these chips do is when the DCD line on the adapter goes high, it produces an event which is visible to the host the next time the USB interface is pulled. So the result is, once I figured this out, I realized all we have to do is wire these two pins together, and we'll get that 50 nanosecond pulse with a jitter which is equivalent to the USB device's polling time, which is normally 125 milliseconds, but hey, you can crank it up to 8 megahertz, and suddenly you're at a millisecond polling, a millisecond jitter. So now, with one additional circuit board trace on the bog standard GPS design, we have a timing GPS with millisecond accuracy for less than $100. So once I figured this out, what am I going to do about it? Well, I need to find an electronics company that is willing to fabricate these for me. Okay, so here's where we take a sort of right turn into science fiction, and I find myself in a William Gibson novel. Because I figured, okay, so I want to find out one of the outfits that cranks out these GPSs by the ton in Shenzhen or somewhere else in the Pearl River Valley. And I'm doing some research, and I find a site called Alibaba.com. Anybody know about this? This is a sort of master commercial portal for Chinese manufacturers of everything. You do a product search on Alibaba for a product type, and it will give you a nice neat list of apparently everybody in China who manufactures these things. And here's the really key part. There's a link from each manufacturer's entry in that table to a chat system where you can talk to their trade reps in real time. So there came a night when I spent, because China's on the other side of the world, there's this time zone skew problem. There came a night when I spent an entire night walking down a list of GPS manufacturers, chatting up their trade reps in real time, explaining what I wanted, and asking, can you fabricate this for me? 2 of them did. So that was 3 or 4 weeks ago now. I'm now actually working with engineering groups at 2 different GPS manufacturers in China to whom I have explained this mod in detail. They're building prototypes. One of the groups actually shipped me prototypes, and they didn't work because it turned out that the USB adapter chip sucked. It's a thing called a CP2101. Don't go anywhere near it. And the reason I say don't go anywhere near it is because, familiar story, when the Linux people wanted to write a driver for it, the vendor refused to release enough information to let them do a complete job. And as a result, the crucial call, which is wait on handshake line state change, isn't supported for that driver the way it is for the PL2303 and a couple of others. So stay away from that chip. And we've had one set of prototypes fail because it turned out that wasn't well enough supported. We've got another set of prototypes from the second company that is known to me to be working because they have tested it with GPSD in China, and they sent me the test logs so I could see the PPS pulses coming through. But they're working on some kind of physical connector problem because there's not enough room in the enclosure. I don't quite understand their Chinese, but they say they need to rework the design a bit, and then they're going to send me more samples. But I want you to step back and think about this. I'm not a hardware guy. I'm not a corporate R&D department with $1 million budget. And yet, I am designing a genuinely new product. When these things hit the market, we're going to have millisecond precision time sources that cost about $30 to $35 each. That's never happened before. There's a huge gap in the market between GPSs with 1 second precision and these laboratory-grade $10,000 systems, which this sits right in the middle of, and it's got lots of uses. Network delay tomography is one. Also, 1 millisecond precision is enough so that you can use it to drive a Stratum 1 NTP time server. It's a fairly large market all by itself. And this is why I kind of feel like I'm in a William Gibson novel, because here I am as an individual negotiating with these fab outfits to do a design to my specs. Cool. Yeah, back there.
A small comment for you. I'm a ham radio operator and a member of an organization called AMSAT.
Yeah.
Amateur Radio Satellites. We've been launching ham radio satellites for 30, 40 years now.
Yeah.
We've run into very, very, very serious problems now in designing and building new amateur radio satellites and getting them launched for us. It's called the War Munitions Treaties and stuff. You will get your ass in jail if you're not careful with this device. You better make sure you've got clearance. This is no doubt going to be classified as military-grade weapons materials and IP technology. Just communicating designs with other engineers around the world, hobbyists like you are basically, nearly got some of our boys in jail.
Wow.
So don't.
All right.
Here with anything, get in touch with the AMSAT board of directors and whatever else, because they're not fooling. They shut us virtually down forever after a 40-year hobby of putting, stuff in space, and we had years of trouble trying to make sure our guys didn't retroactively, so.
I can edit that out if you want.
No. No. My best defense about that kind of thing is lots of publicity. I want to make it politically difficult for those assholes to jump on me.
You will find that you have all the right in the world to write as much as you want from jail, just like Alexander Solzhenitsyn did.
But you've been very patient.
No, that's right. So I didn't think of his issue. It's a real issue. I ran into something like that 20 years ago, where I had all kinds of clearance from Defense Department and Commerce, but it was state, because they were concerned about encryption and they consider that a munition. So I would say go to the State Department first and then hit up the others if you're concerned about it. My actual question was, there was a wonderful story you told about how the world has changed and you can do this, and I was thinking, well, now some patent troll is going to come and come after you.
And no, they won't, because I'm going to have prior art in 3 weeks.
Are you sure it's prior art? That's the thing.
Where
do these people come from?
It's one circuit board trace. It's one single circuit board trace.
Seemingly enough. But it's something.
First to file is now the rule,
something
isn't
that's
it?
patentable
Is that-
for you.
But I don't want to patent it. I'm not an asshole.
But there's a difference between patenting and actually forcing
Right, you
people
could
to pay
patent
for the
it for
license.
your freedom to continue doing it.
You need to disclose it, you need to publicize the innovation.
Right.
Yeah.
Put it in the public domain.
Yeah, I should. Well, and I've already done that. I've
just
been
did,
blogging
yeah.
about this. I've been broadcasting the news all over. So, nobody's going to be able to say this with public knowledge. But my objective from this is not it is not to corner the technology myself. What I want to do is raise the bar so that all of the GPS manufacturers believe correctly that they have to do this to stay competitive. What I want is for the market to be flooded with cheap time sources so that it's easy for our volunteers to get them. That's the outcome.
So you're hacking the market.
Yeah, I'm hacking the market. And that's kind of Gibsonian too, isn't it? It's also very much me.
Good luck.
Yeah, well, thanks for the warning. I'm not seriously worried, but maybe I should be.
Yeah, there are some issues, by the way. Getting raw GPS time is not always enough. We can talk afterwards.
Yeah, I know about the thing is that once you've got top of second, there's some tricks you can play to condition your local clock, and I'm going to be doing
as long
those.
as you're aware of them.
Yeah. Yeah.
You're talking about hacking the market. Richard Stallman thinks he envisions he's the GNU keeper of GPL, or at least he was instrumental.
Yeah, trust me, I've known RMS for a long time.
Yeah, I wasn't saying that for your benefit. But he envisions a very radical transformation of our whole industry, right? I mean, that's his whole thing is that, well, if commercial software distribution as we know it today doesn't support the 5 things that Richard believes in, then that has to change.
Mm-hmm.
So do you envision transformations that may happen in the next 10 years, even if they're not as radical as what Richard is saying?
So the implied question is, am I on board with Richard's radical transformation? If so, to what extent?
Or is there something?
Well, I mean, I like to think I've already transformed the industry. Otherwise, what am I doing here? I mean, we live, at the very least, we now live in a situation where lots of people can use and enjoy open source tools, and an increasing number of people can make a living writing and maintaining them, and that's a good thing. Do I want to see all software become non-proprietary? I mean, it would particularly bother me if that happened, but it's not a major objective for me. As you know, it doesn't harm me that other people write proprietary software as long as they don't try and infringe on my freedom to write software the way I want to. And well, that's the freedom I'm concerned with protecting. I want people who voluntarily choose to be part of the open source community to be able to continue to be part of it. And as long as that objective is achieved, what other people do is not really of much concern to me. Do I think we will be seeing radical transformations? Well, let's talk about a radical transformation. This is an Android phone in my pocket. Android went over 50% US market share 3 months ago. This means that for the first time, Linux has majority market share in a consumer-facing product. And people, that is big. You want to talk transformation? I'm holding transformation right here in my hand. So you should all go encourage your friends to buy Android phones and speed things up. And no, I'm not actually saying that just as boosterism, because I have an idea about where I think computing is going to be going in the future, and let me rant about that because it's partly an answer to your question and partly a natural follow-on. This is something I predicted on my blog several years back, and if you guys actually like listening to me rant, you can hear me rant anytime. Surf over to Armed and Dangerous and read my latest blog entry. And I talk about a lot of the things I've talked about tonight. The thing I wrote about on my blog is I think that one of the things that's going to happen next is that computing, personal computing is going to disaggregate in an interesting way. I think we're headed towards a future where this, or its descendant, is my primary computing device, has all my stuff on it and the programs that I use. And when I'm walking around not doing anything but being a human being, I just use it as a phone. And when I want to sit down and write code, I walk my device up to a screen and a keyboard, and I sit down and I write code. And the device is always connected to the internet, and it's always connected to whatever cloud storage I have. That's always connected to whatever backups I have. The point is, I get to carry my entire digital world around with me, and it's disaggregated from the peripherals that I use when I'm in coding mode. It's disaggregated from the big monitor and the keyboard and all that stuff. I think that's where we're headed, and I think that's why it's tremendously important that the dominant smartphone platform is now open source, because that means we won. That means we won. Yes?
It's funny that you say that, because just recently there was a IDE release for developing Java Android apps right on the phone. So I can take this home, I dock it to my computer, and I can write Java code right off the phone.
Better than that, there is now an Ubuntu product that you can install on your Android phone, and you plug it into a monitor, and suddenly you've got an Ubuntu desktop with all of your Android applications available inside it in case you still want to use the thing as the phone. This is the future, people. This is where it's all going.
How does Object-C compare to like Java, ME?
Oh my God, he brought up Objective-C.
I'm just curious, yeah.
You know, I don't know it well enough to criticize. What I hear isn't real good, though. May like to think that they control a communications choke point, and for voice traffic they do. But if we're looking at the smartphone as a PC replacement and as a data communications device, the carriers don't actually have control of that choke point.
They won't let you buy a smartphone without the data. Oh yeah. You can, but they won't connect you.
I could do it tomorrow.
You can buy an unlocked phone. You can buy an
you buy an unlocked phone and just use it in Wi-Fi mode. It's not a problem. Yeah.
Having a whole, well, for me, that's a lot.
Me too.
Okay, so the question that just came up is, what do I think of the whole Oracle Google lawsuit? It's a joke. It's a joke, and the magnitude of Oracle's claims has been steadily whittled down till it's now approaching nothing. And that's where it's going to go. So does that come to the end of the future of computing question?
Does that sentiment apply to all the patent wars going on within
Well,
the
you
global
know,
industry?
when you look at all the patent wars that have been going on, there's been a great deal of sound and fury and very little tangible result. And I think the people in the industry who have been shoveling millions of dollars down a lawyer rat hole are beginning to wake up to that. That after all the thrashing, there doesn't seem to be much change in anybody's positions.
Like Samsung and Apple are actually talking now.
Yeah. So, next, yeah.
One last question about the GPS. If I have a USB GPS, will that work with the same package you have?
No, because your GPS doesn't have the magic PCB trace inside it to connect the one PPS to the PCB. Yeah. You have to have that hardware mod or you're screwed. That's the only difference. And you have to be using a USB adapter like a PL23303 that Unix will actually support, but that's a secondary issue. Yeah?
Kind of taking the GPS, when you were talking about that, it seemed to me perfect use for Arduino, that you have the chip, you have the chip on a shield.
You know, this is a good question to have come up in front of geeks because it lets me rant about solutions that don't scale. He said, you know, this seems like a perfect use for Arduino. You know, you put together an Arduino chip, a shield, and a GPS chip. When I first floated this problem to a bunch of my friends, they all came up with answers like that one. And I had to be the guy that says, we have to deploy 100 units. We can't hand build 100 units. And if we could hand build 100 units, we couldn't maintain them afterwards. So there's an issue here with solutions that scale. Hand building with Arduino, great idea for a hobby project. Great idea if you're exploring what's possible and don't intend to go for production. If you're talking field deployment all over the world of hundreds and possibly thousands of units, no way.
But if you contract with your Chinese supplier to build a shield.
But I'm already doing that, and I didn't have to go the Arduino route. I just came up with a trivial mod to an existing design. So, yeah, you know, this is something I actually wanted to say about my hardware designing adventure. What I'm doing is not just hardware. It's whole systems engineering. I'm thinking about the hardware, I'm thinking about the software, I'm thinking about the economics of sustained production, about the deployment issues, and you know what? I love it. It's fun. It's actually more fun than just looking at the software. Whole systems engineering. Try it, you'll like it. Next question. Back
Talk
here.
about CISPA and PIPA and SOPA and things like them, and what sort of trajectory you think we're on, and if you think we can do anything about it?
SOPA, PIPA, the fucked up acronym of the week. What kind of trajectory are we on, and what can we do anything about? Well, I mean, we can only do what we did the last time, which was oxygen of publicity and make life politically really, really uncomfortable for the idiots sponsoring these things. We did it last time. It worked. We'll probably have to do it again, and it will probably work, and we'll probably have to do it again, and again, and again, and again. We'll just have to work that as often as we need to. I mean, there's no magic formula. There's no answer I can give you. There's no button I can push that says that this crap will never happen again. The only way that you solve this kind of problem is by taking design and people's personal lives and everything else as far away from the reach of politics as possible. Next. I sense that we may have reached a saturation point. Over there.
Are you planning on writing another second edition of the program?
Oh, yes, that was one of the questions I meant to answer. Yes, I'm talking with Addison Wesley about a second edition of the Art of Unix programming. It probably won't take all that long, as I have already had most of the changes that I need to do queued up. And we did a lot of the hard part, getting the manuscript ready for the first publication. There will be substantial additions to Chapter 13 just after the book went into print the first time. I blundered into a wonderful case study on whole systems optimization and the value of that timeless maxim, when in doubt, use brute force. And that's going to be in the second edition. And also, my editor said an interesting thing when I went back to him and said, I'm thinking about releasing a second edition as an ebook, but I feel like you guys treated me very well, so I have kind of an ethical obligation to say, do you want to do the print book? And he said, yeah, actually we do. We're much more interested than we would have been 3 or 4 years ago. And the reason he gave me is Android. And the rise of Android gives the whole Unix tradition thing, from the publisher's point of view, much more relevance than it had even a couple of years ago. And I rubbed it in. I said, hey, it makes me sound kind of prophetic, doesn't it? I said, yes, it does. So yeah, there will probably be a second edition sometime in the next 18 months to 2 years at the outside, maybe sooner. It depends on how much other things I can clear off my plate. I saw another question over there. Okay, maybe there wasn't.
Speaking of Unix and useless lawsuits, what's the whole situation with that SCO IBM lawsuit? What's
That's still around.
Dead.
SCO is dead. Shall we see?
Yeah, it's dead. The SCO's corpse is still feebly twitching occasionally, but there's no chance they're going to get anywhere. They're 3-time losers at this point. They're a joke. Yeah, and I can't give any details in public, but I could drop the tantalizing hint that I had something to do with this. What was that?
I said changing the fund definition.
Okay, anything else, or are we done?
When you
Yeah.
When you started working on GPSD, what itch were you scratching? What were you trying to do for yourself?
Oh, that's a really good question. Yeah. When I started working, the question was, when I started working on GPSD, what itch was I scratching? Well, at the time, I had just gotten introduced to GPS as a technology, and the idea that I thought was really cool was there's this piece of software called Kismet, which is a war driving mapper. And one of the features that Kismet had was that if you assembled the right bits and the right software together, you could use Kismet to produce contour intensity maps of the availability of Wi-Fi access points. And for some reason, this really grabbed my imagination. I loved the idea of wandering around my neighborhoods and producing isobar maps of where the access points were reachable. I never ended up actually doing this because it turned out that the maintainer of Kismet was kind of difficult to work with in some ways. But that was what got me interested in GPSs. And so I went looking for software to work to make my GPS talk to my to Kismet. And I found GPSD, which at the time had a lot of dust on it because the maintainers mostly lost interest in it and had been sitting there for several years. And so I looked at it and I said, this is actually really kind of interesting. And I spent a weekend on it, and I implemented the entire feature list in there to-do over that weekend, and several things that I thought were interesting. And I began to see it as an interesting system architecture problem. If you ask Dave Packard, who was the other major designer of X, he'll tell you, I'm not actually that interested in graphics. It was just an interesting system design problem. Well, that's how I am with GPSD. I saw a lot of potential in the design, if it were, that it could be a really beautiful thing if it were factored properly. And so I started refactoring it and adding some features and extending the protocol. And I think the main conceptual breakthrough in my work with GPSD, well, one of them anyway, happened when I realized that potentially there was a way to eliminate all the configuration garbage. Tell it your GPS type, tell it your baud rate, tell it your parity, tell it your number of stop bits. I'm looking at this, and at the time I had been reading a lot of stuff about the Macintosh approach to user interface design, which is, never, the user should never have to tell the computer anything the computer can deduce for itself. And so I asked myself the question, is there some way that the computer could deduce all this configuration instead of having it handed to it in a configuration file? And then I remembered this technique from the dark ages called autobotting.
Yay.
Anybody remember autobotting? Yeah. So it turns, there's this ancient technique which we used to use back in the days of like 1200 baud modems, where if you happen to know in advance the data pattern that was going to be coming down a serial device in its ready state, you could sync to that pattern in order to figure out what baud rate the port was actually at. And one of the things that I knew about GPS devices is almost all of them ship their data in self-describing packets with a fixed header, a fixed trailer, and a checksum. And the fixed header and the fixed trailer are different for each protocol type. Brain, are you seeing what I'm seeing? I realized that the incoming GPS data stream had all this stuff in it I needed to autobot. What I needed to do was I needed to write a deterministic finite state automaton that would recognize all these packet types, and furthermore, I needed to autobot so that it would keep cycling through possible communication settings until it hit one where it saw a known packet type, where it saw a known packet header and a known packet trailer. And the clincher was, because the packets were checksummed, I could tell within a very high probability when I was seeing real data as opposed to random line noise that happened to be masquerading. That was the breakthrough. I realized GPSD doesn't have to be configured by hand. What it has to do is know how to configure itself by snooping the data stream. And that's exactly what I did, and that's exactly why, even though there are GPSs behind all your location-aware Linux applications, there's no setup screen. You don't have to tell the application or GPSD what the GPS type is. GPSD figures it out, and that's how it does it. It knows that there's this fixed inventory of packet types that could be coming down the wire, and it keeps checking for different communication settings and different packet types until it gets a lock, at which point we're golden. That was the major conceptual breakthrough, and since then, I did one other major thing, which was redesigning the protocol. We were running out of protocol space, and the request response protocol was this really primitive thing where the responses were designated by single letters. So once you had 26 responses, you were done. Ow. Never do that. Because you will always run out of space. So eventually I realized we were going to have to redesign the protocol, and then I spent 3 years wrestling with that problem. And I didn't redesign the protocol for a long time because I had this sneaking sense in my head that I didn't understand the problem properly because all of my solutions were too complex. I was right. And this lasted until I read about JSON. And I thought, I don't have to design my own custom protocol. All of these reports, these time, position, velocity stuff, and the satellite views and everything else, they want to be JSON objects. They want to be JSON objects coming up the pipe and being interpreted by a JSON parser on the client end. And that's what I did. And that was big too, because once you've taken that step towards your daemon is this thing that's watching sensors and occasionally emitting JSON objects, now what you have is a sort of generalized serial sensor handler bus, where every time you get a new device driver, it can just, if it can't emit one of the existing JSON objects, it just emits a new one. You've just enriched your sensor feed, and anything that cares can interpret those objects coming up the pipe and ignore anything it doesn't want to know about. This is powerful. So now we're looking at a future where I've already folded in support for marine automatic identification system transponders. I expect sometime in the next 5 years to do aircraft transponders. Eventually, and we just had support for like depth sounders in your boat put in, so eventually what GPSD is going to turn into is this oracle that periodically delivers objects that tell you everything about where you are, how you're moving, and what's near you and how it's moving. That's where it's going. And that's an interesting problem. Yeah.
Add in weather and transmit that to flight service, and then I won't have to call them.
And I'm certainly open to doing more aviation-oriented stuff. The bottleneck there is currently the data protocol for transponders isn't rich enough that I can use it. That's going to change when they go to version B in a few years. And I would love to, if I had a domain expert, I would love to do things like APRS. So, yeah. Yes? Yeah, go ahead.
APRS, ham radio.
I would love to do something like that. I just don't know the standards or have a domain expert on my project. Oh, okay. That's one. Join my project. Was that more or less an answer to the question you were trying to ask? Somebody was trying to ask what itch was I scratching.
Yeah, it's definitely.
So that's the itches that I've been scratching. Okay. Any more questions? I see one person waiting.
Yeah. So I'm going to return to functional programming. So I'm not a hardcore programming, and I don't really know what that means. So can you give possibly a real-world example that would be well matched to being solved by a functional program?
A real-world example that's well matched to being solved by a functional program. What was the last purely functional program that I wrote? I'm going to give you a more general answer because I can't think of any specific examples right now. There are lots of kinds of programs where you are essentially walking over a bunch of complex data structures and generating a report which then gets passed on to a later stage of processing, some kind of digested or summarized or computation value added report. Functional programming languages are really good for that sort of thing. They produce very clean programs. It goes with the advice that I've given in my papers, and which goes all the way back to Brooks, which is that dumb programs and smart data works much better than the other way around. You always want as much of your complexity as possible to be in your data structures being munched on by simple walkers. And functional programming languages are very good for that sort of thing. Next. Wow, I've exhausted everybody.
While we're on the topic of functional programming, can you look at Clojure?
Clojure is in the same category with Scala. I know I have to look at it soon. I haven't yet.
Evolutionary programming?
Evolutionary programming. Tell me what you think you mean by that.
Evolutionary algorithms using any background on this?
Nope. No, nothing about it. The question was about evolutionary programming. I mean, I think I've run one basic textbook on it, so I'm familiar with the concepts, but I don't have any practical experience with it.
Erlang?
It doesn't smell good to me. I'm not sure why. Maybe I need to give it a second look. Erlang was what the question was about. I'll tell you one concurrency thing I am really pleased by. I have been wondering since about 1971 why nobody took the ball and ran with Hoare's communicating sequential processes model. So elegant, so pretty, so nice to reason about. And 40 years later, the Go people picked it up and ran with it. That's one reason I'm looking at Go. CSP is the basis of the concurrency model in that language, which is enough to motivate me to want to look at it some more. Next. I note that it is. It's 8:30. My God, we're half hour over time. Go home, people.